Hi class, this is section 7.4, evaluate and graph logarithms. We've got a few big questions on this one. So let's look at our big questions first. The first one is can you rewrite an exponential to log form and log form to exponential form? The next one, can you find the inverse of an exponential and logarithmic equation? And the last, can you graph logarithmic functions and describe the characteristics of the graphs? So we're going to be doing quite a bit with logarithms today. This is a new idea, a new topic for you. The thing you need to keep in mind is that we're solving these and using them because logarithms are the inverse of exponential. And you've studied inverses before. Remember, that's where you switch your x and y and you solve for the y. But logarithms we use to help us solve exponentials to find some of our So look at your frame here. Let's look at our frame. So evaluate and graph logarithms is about rewriting exponential form into logarithmic form in order to be able to find an exponent. So make sure you've got that filled in, rewriting exponential form into logarithmic form in order to be able to find an exponent. So the first couple things that we need to know here is you have to be able to convert between log form and exponential form. Because we're going to use this converting between forms to help us evaluate logarithms. Our calculator can't do all of these. You have to do quite a bit of this by hand. So let's start filling this frame in here. So exponential form, our basics, look like this. Y equals b to the x power. And the log form of this would look like log. We use the word log. In our base, we put as a small number, a small subscript right here. So log base b. And what's on the opposite side as the base, our y, goes right next to it. And it equals the exponent. And that's why we can use logs to solve for exponents. So you would read this. Log base b of y equals x. And this is y equals b to the x power. So our exponent ends up being over here by itself. Our base ends up being right next to the log. And then what it equals ends up being next to the base. So common logs are logs of base 10. So the common log, the most common one we use, is a log of base 10. And then this is what you see on your calculator. There's a log button on your calculator, and the log button on your calculator does log base 10. We also have natural logs, and that's a log of base e, which we've talked about what e represents in the last lesson. So log base e of x, and that equals, we have got this button on our calculator as well, it's ln, the natural log. So ln stands for natural log. There's a natural log button on your calculator, and it's just log base e. So switching between forms, this is something you have to be able to do. If you notice, here's my base, and I said the exponent is what's on the other side of the equal sign. So we'd say 2 to the 5th equals 32. So this is just 2 to the 5th equals 32. And let's go in the other direction here. So here's our base. So we're going to say log base 1/2 of 2 equals our exponent, equals -1. So it's log base 1/2 of 2 equals -1. So that's how we go in between them. So let's evaluate some logs without using our calculator. So let's try and do some evaluating here. I'm going to make this a little bit bigger so I have a little bit more space to write. Sorry, I kind of turned it a little bit. Okay, you can write a little smaller. My pen doesn't write very small. Okay, so this is log base 3. It doesn't show up very well on mine, but this is supposed to be log base 3 of 81. Okay, so we make this equal to x. When we want to simplify, we set it equal to x. So that way, I can say 3, my base, to the x power equals 81. And then you have to simplify and think about 3 to the what power is 81? Well, it's 3 to the 4th, so x equals 4. So my answer here is x equals 4. The natural log of e to the 36th, we're going to put equals x because we don't know what it is. And remember, with natural log, my base is e. So I can change this into my base e to the x power equals, and then e to the 3.6. That's what's next to my base. Well, if you look right here, I've got an x as this exponent and a 3.6 as this exponent. In order for these two things to be equal to each other, my exponents have to be equal to each other. So this is actually pretty simple. X equals 3.6. And there's your answer. Okay, this next one, I'm going to set this equal to x. So I'm going to say 8 to the x power equals the cubed root of 8 squared. Okay, so this is 8 to the x power equals the cubed root of 8 squared. And remember, a cubed root, we can really make that to the 1/3 power. So I can say this is 8 to the x equals 8 to the 2/3, because 1/3 times 2 would be 2/3. So now we have x as the exponent here and 2/3 as the exponent here. So we know x equals 2/3. So what we're really trying to do is make it so that we've got the same base on both of them. So number 4 here, I can set it equal to x. So my base is 49. This becomes 49 to the x power equals 7. Well, if you think about it, it's the square root of 49, which is 7. And instead of doing the square root, though, that's the same as the 1/2 power. So my answer here, x equals 1/2. Because 49 to the 1/2 power, that's the same as taking the square root of 49. Number 5, I'm going to set this equal to x. So this becomes, let's change the formula. My base is 1/4 to the x power equals 256. Well, one hint for this one is because this is a fraction over here, 1/4. I've got to think 4 to the what power equals 256. And in order to get that 4 out of the bottom, this exponent has to be a negative number. So I think, well, 4 to squared is 16. And if you just test it on your calculator, because you're not sure exactly what, you'll find that 4 to the 4th is 256. And in order to get rid of this fraction, I got to make it 4 to the negative 4th. So my answer is x equals -4. And there's your answer for that one. Let's look at the next. So here are some special log properties. Okay, these properties are going to help us in later sections to simplify some problems. So the first property is log base b for any base of 1 equals 0. And the y, well, if you think about it, b to the 0th power, anything to the 0th power is 1. So if I evaluate the natural log of 1, remember that's natural log has a base of e. So this is really e to the what equals 1. Well, it's e to the 0th power, because anything to the 0th power is 1. The next one, log base b of b equals 1. The y here is, if you think about changing the form, my base b to the first power equals b to the what power? Well, if you think about that, our unknown would have to be 1. So log base 11 of 11, well, that's got to equal 1. And if you change your base here, that'd be 11 to the first power equals 11, and that's true. The next one, log base b of b to the x equals x. Why? Well, if I change my form here, my base is b to the x power, because x is on the other side of the equal sign, equals, what's next to my log base b? Well, that's b to the x. And we know b to the x does equal b to the x. And the thing to remember here is that your bases cancel. When we have bases that are the same, they're going to cancel out. And that's a lot of times what we're going to try and do is get our bases the same. So here, I've got 3 to the, well, we got to figure out what it is that we have here. So 3 to some power equals 27 to the x power. And 27, this 27, if you think about it, if I want to change that to a power of 3, well, that's 3 to the 3rd power. So I can actually make this 3 to the what power equals 3 to the third, that's the same as 27, times x. So my what power here is just 3x. The next one, b to the log base b of x equals x, and the y here is bases cancel. We know this is true because our bases cancel each other out. So if I have 10 to the log, and remember this is log base 10, anytime, see we don't have a base here, so anytime you don't have a base written there, it's automatically 10. So we know this 10 and this log base 10, they're going to cancel each other out. So we're just going to be left over with 7x. Column here. Inverses are steps to finding inverse, and you might just want to write these 2 steps right up here. This would be a good spot for you to write them. I'm not going to put them there because I don't have space. I'm just going to put them on the side. But you should put your 2 steps right here to help you remember to write inverses. And you've done this before, so it shouldn't be too bad for you. The first step is to switch the x and y. Our first step to finding inverses are to switch our x and y. And then the second thing to do is solve for y. And what you need to remember here is when we're going to solve, we often have to change forms. We're going to use changing forms quite a bit to solve for our y. So find the inverse of y equals 7 to the 2x power. Well, one thing that you've got to remember to do is you're going to switch your whole x quantity when it's in an exponent. Okay, so put a little star to remember to do that, so you remember it in the future. Switch entire x quantity when it's an exponent. I'm trying to write as small as I can here. Switch your entire x quantity when it's an exponent. Okay, so let's do this. So 2x is my entire exponent there. So in place of y, I'm going to write 2x equals, I'm going to keep my 7 in the same spot, and my exponent now becomes y. So I switched the 2y and the y. So now we want to change our forms here. I did my first step there, I changed my forms. Now let's do our second step here. So it's going to be log base 7 of 2x equals y. Y is all alone, so this is my final answer right here. Okay, I found the inverse. Next here, find the inverse of y equals the natural log of x plus 6. So first of all, let's switch our x and our y. So instead of x or y, I'm going to put x equals the natural log of y plus 6. So I did my first step, I switched it. Now my second step, to solve for y, I'm going to have to change forms. And because I have natural log, because I have the natural log, remember you could say the natural log is base e. Because I have that, I have to say e to the x power, because e is my base, even though it's not written. E to the x equals y plus 6. And then if I subtract 6 from both sides, I have e to the x minus 6 equals y. And there is your final answer. It's solved for y, so that would be our inverse. Okay, let's statement on this frame. So down at the bottom says the domain and range of log functions are opposite. Okay. Oh, I'm looking at the wrong one. You do need to flip your page over at this point. So let's flip our page over. Okay, let's flip our page over. And let's start by filling in our is about here. So this is about when you graph log functions, you've got to think about the exponential form and make a table of values. So we're going to be making tables of values as exponential forms. And so instead of plugging in and finding our x value, or plugging in x values and finding y, we're going to do the opposite. We're going to plug in our y values now and find x. Okay, so a thing to remember, let's think about our so what right now as well, as long as we're on here. What you have to remember is the domain and range of log functions are opposites. They're going to be switched from exponential functions, and this is because logs and exponentials are inverses. So our domain was always all real numbers when we did exponential functions. Our range now is always going to be all real numbers. So let's try an example problem. So example 1, graph log of x. Okay, now this is always going to be log base 10 when it's not written. Okay, so log base 10. It's my log base 10. So I want to find it my exponential form. So this is 10. If I switch my forms here, this is 10 to the y power equals x. Okay? We're going to make a table using the exponential form. And if you notice, your exponent is y. So we need to plug in values for y. So I'm going to plug -2 in for y, and -1 in for y, and 0 in for y, and 1 in for y, and 2 in for y. So let's see what this ends up looking like here. If you plug -2, 10 to the -2nd power is 1 over 100, so that's 100th. If you do 10 to the -1st, that's 1/10. 10 to the 1st power, or 10 to the 0th power is 1. 10 to the 1st power is 10, and 10 squared is 100. Okay, so let's put these points on our graph. And you've got to remember, we're kind of doing things backwards here, so it might get a little confusing at first to graph. So 100th would be just over slightly, -2 would be right down here. So 100th, -2 would be right about here. 1/10, -1 would be right about there. So 1/10, -1 is going to be right about here. 1, 0, so 1, 0 is right here. And then 10, 1, well 10 is going to be way over here, and that's kind of off our graph. So we're just going to use these 3 points because these are the 3 that we can fit on there. So I'm going to draw my nice curve in here. It's going to look something like this. Okay, so our y-intercept here doesn't really cross the y-axis. If you look at it, because it's the inverse, now it approaches your y-axis, but it never ever touches and never ever crosses it. Previously, we had it approach the x-axis and never touch and never cross. Now it approaches the y-axis. So we can't do a y-intercept because it doesn't have one. So we're going to change this to our x-intercept. And our x-intercept is the point 1, 0. Told you our domain and range is going to be switched around. So our range is now going to be all real numbers. Our domain is going to be all real numbers. And if you think about all my x's here, they have to be bigger than 0. So it's all real numbers greater than 0. We need to draw our asymptote in here. Our asymptote is right here. This is the line that it's going to approach but never ever touch and never ever cross. So our asymptote is the line x equals 0. And previously for our transformation, we would look at our parent function going right here through the point 0, 1. Well, if you look at this, this goes through the point 1, 0. So that tells us there is no transformation for this one. So there is none. So we've got a little bit different graph. Let's look at the next one. So example 2, graph y equals log base 1/3 to the x power. So let's change our form here. Okay, our base is 1/3. So we're going to do 1/3 to the y power equals x. And this is the exponential form that we're going to use to graph. So xy, making my table, and I'm going to use my y values again of -2, -1, 0, 1, and 2. Okay, now we don't have any translations here. There's no movements again. So my domain is, or I'm sorry, my range is still going to be all real numbers. Remember, we switch those around. Your range, well, my base, 1/3, is a positive number. So my domain here is going to be all real numbers greater than 0. My asymptote is still going to be the line x equals 0. Now let's draw this in here. There's x equals 0. And if we think back to exponential form, the a value for this, the number in front, would still be 1. So there's no transformation here. So there's no transformation. Well, we got to put none. And because there's no transformation here, our x-intercept, remember we're changing this into our x-intercept, is still going to be 1, 0. 1/3 to the 0th power is going to be 1. So we've got 1, 0 right here as one point that we already know. And let's just do the rest of them. 1/3 to the -2nd is 9. 1/3 to the -1st is 3. 1/3 to the 1st is 1/3. And 1/3 squared, yes, 1/3 squared is 1/9. Let's now plot these points. I'm just going to pick a different color to plot these points in here. And if I tried to graph 9, -2, that would be definitely off my graph. So I'm going to graph 3, -1, which would be right here. There's 3, -1. 1, 0 is going to be right here. 1/3, 1 would be right about here. And 1/9, 2 is going to be really, really close right about here. And I'm going to fill in the graph as nicely as I can. It's going to approach that line x equals 0, but never ever touch and never ever cross it. And there's my graph. Let's look at the next. Okay, so now if you notice, we've got this y equals log base 3 of the quantity x minus 1, and then we've got that plus 2 at the very end. So we're going to have to do some translations just like we did before. And as we did before, this minus 1 right here, that's going to tell us to move our graph right 1. And then this plus 2 at the end, that plus 2 is going to tell us to go up 2. So let's think about the exponential form that we want to make a table for. Our basic, without any translations, would be y equals log base 3 of x. So this is really, if we change our form, 3 to the y equals x. So that's the table that we want to make. 3 to the y equals x. So I'm going to make my table. Plug -2, -1, 0, 1, and 2 in. And 3 to the -2nd power is going to be 1/9. 3 to the -1st is 1/3. 3 to the 0th is 1. 3 to the 1st is 3, and 3 squared is 9. Okay. So let's put these points on our graph. Let's put these on, and then we'll talk about our y-intercept, our domain, range, asymptote, transformations, things like that. So let's put these on here. 1/9 -2 would be right about here. 1/3 -1 would be right around here. 1, 0 would be right about here. So if we look at that, right now we know that this isn't stretched at all because it goes through that point 1, 0. So there's no stretch. Our only transformation that we're going to do is to go right 1 and up 2. So let's write that down. Our transformation is right 1 and up 2. We know there's no stretch because of where that x-intercept is at. 3, 1 would be the point right here. And then 9, 2 is going to be off of our graph. Let's now take these 3 or 4 points in green and make this right 1 make this right 1 up 2 movement. Okay, so if I take this point right here, if I go right 1 and up 2, I'm going to be right about here. So right 1, up 2 would put me right about here. Let's take this point, go right 1 and up 2, and that would put me right about there. This point, and this was my x-intercept, so this is actually going to be, we're going to call it our starting point again. If I go right 1 and up 2, it's going to be at that point 2, 2. So that's a special point on our graph. So I'm going to call that my starting point. And that's the point 2, 2. It's a special point, so we're going to put that right on there. And then this point, if I go right 1 and up 2, it'll be right about here. So I'm going to draw my curve in. There's my nice curve. Okay, so let's talk about our domain. Our domain here is going to be all real numbers. So we're talking about all of our x values. I don't have any of these. It's going to be all real numbers greater than 1 because they're all bigger than 1 here. So all real numbers greater than 1. Our range is all real numbers. We could plug in any y value we wanted to. Our asymptote is going to be the line x equals 1 because our whole graph moved over 1. And let's draw that asymptote right in here. So my asymptote is right here. And one thing I did a little bit differently is instead of drawing that first curve that I graphed this time, I only put the points in there. That could be another way to help you see which is your actual graph. Instead of highlighting it when you do it the first time, you could just put the points in. Okay, let's do one more problem. Okay, we want to graph y equals log base 1/2 of to the x and then minus 3. Now notice there's no parentheses around this. Okay, so that minus 3 does not go with the x. This minus 3 is at the very end, so that's going to tell us to move our graph down 3. If there was parentheses here, then that would tell us to move our graph to the right 3, but there's none. So this right here, that tells us to go down 3. So we know right now we're going to have a transformation. Our transformation is going to be down 3. So I'm going to put that right now under my transformations, down 3. You should know at this point too that your range is still going to be all real numbers. And because we're not moving the left or right at all right now, your domain is still going to be all real numbers greater than 0. And your asymptote is still going to be the line x equals 0 because we're not having any movement to the left or the right. So I'm going to draw my asymptote right in here. There's my asymptote. My starting point, I'm going to use a starting point again this time. And let's wait and see what that is. So I'm going to use the equation y equals log base 1/2 of x. I'm going to make my table for this equation, and then I'll make my movements of down 3. So this is really 1/2 to the y power equals x. That's what I want to make a table for. That's the exponential form. So x, y in my table. I'm going to use -2 for my y, -1 for my y, 0, 1, and 2 for my y value. So 1/2 to the negative second power is 4. 1/2 to the negative first power is 2. 1/2 to the 0th power is 1. 1/2 to the first power is 1/2, and 1/2 squared is 1/4. So here's my table of values. I'm going to put those on my graph. So 4, -2 is right here. 2, -1 is right here. 1, 0 is right here. And if we think about it, It goes right through the point 1, 0 right there, so there is no stretch to this graph at all. So my transformation is only down 3. I don't need to add anything more to that. 1/2 1 would be right about here, and 1/4 2 would be right about here. So we've got our points. Now let's make our movements. All these points, I need to go down 3. So if I start right here and go down 3, 1, 2, 3 would be right about here. And this one, if I go down 3, 1, 2, 3, would be right about here. And down 3 for my next point would be here. And for my next point would be here. And then for my next point, down 3 would be right here. And I will now connect these. And there's my nice curve for this logarithm. Okay, so we've got our so what statement already filled in for this, so that is the end of this lesson. Make sure any questions that you didn't understand or didn't quite make sense. Oh, I forgot to put my starting point. My starting point, when I move this piece right here, when I go down 3, my starting point became 1. My starting point became 1, -3. Got to get that in there. Okay, like I was saying, anything that didn't make sense, anything you had questions on, make sure you star them so that we can go over them in class, and have a great day.